It says a coordinate grid has been placed over a city map. The middle school is located at the coordinates 7 1/2, 6 1/4, and the public park is library is located at the coordinates 3 1/4, 2 1/2. Graph and label these two locations. So let's start with that. So 7 1/2, 6 1/4. Do we remember to go over 7 1/2 and then up 6 1/4? So that's about right there. And that is the school. And then the library was at 3 1/4, and then 2 1/2. So that'd be about right there. That's the library. Okay. It says graph and label these two locations. What is the approximate straight line distance between the middle school and the public library to the nearest tenth of a unit? So what are we, if I connected these, about like that, okay? That's what they're looking for, right? Yeah? Okay. And so now the question on the bottom says, how does the Pythagorean theorem relate to this situation? What would you guys say? How would the Pythagorean theorem?
Because if you draw a right triangle, you can use the two x triangles.
Yeah, if I just went ahead and made myself a triangle, sketched it,
Obviously, the other way.
does it matter?
Because our brains usually go down. It's the same.
I still made a right triangle, correct? Either way that you choose to do it, guys, it still would be a right triangle, right? Yes? Okay, and then it says, then what is the approximate distance? Well, this was 2 1/2 to 6 1/4, right? So this is about how far? From 2 1/2 to 6 1/4, approximately. I would say that's about 4, right? Between 2 1/2 is about 2 1/2 to 6 1/2, which is about 4. Does everybody get that? And then we went from a little bit more than 3 to a little bit more than 7. So about how much is that? 7. From 3 to 7 is about 4 as well. That's what I would say there. So then these are my what? Yeah. So then you would do 4 squared plus 4 squared equals c squared, right? And so then that would be what? 16 plus 16 is 32 equals c squared. So then c equals what? 8. I don't think so. Square root of 32, I get 5.7 approximately. Did it say? It didn't say. Oh, yes, there's 10. Okay. Again, it was approximate. Technically, these numbers should be a lot harder, right? Yeah, because of these fractions right here. But because they said approximately, I would say we did a job approximating. Okay. All right, you guys. Okay, so today we're talking about Pythagorean theorem on the coordinate plane. Okay, so we probably have that one up, right? It says sometimes finding the distance between points on a coordinate plane is as simple as looking and counting. I'll go graph A. If I wanted to know between these 2 points the distance, what is it? I'm sorry? 3. Because we count the squares, correct? Okay? But other times, like on graph B, we're looking for a diagonal distance. Okay? So to find the diagonal distance on a coordinate plane, we created our own what? Right triangle. And just like the warm-up, I could do it this way, or I could have gone on the bottom and up. It doesn't matter. And use the what to calculate the distance? Thank you. Pythagorean theorem. Because again, that works with every single right triangle. The diagonal distance would represent the hypotenuse or C. Okay? You ready? Okay, so let's actually do it. It says use the Pythagorean theorem to find the distance between points A and B on each graph, round to the nearest tenth. Round to the nearest tenth. Okay, so step 1 is to do what? Yeah, create a triangle. So let's connect them. do what? Yeah, find each side, right? So let's count. Again, we're counting the squares, not the lines. If you count the lines, you're gonna get off, okay? And then this way would be 4. And now we're just gonna plug it in. A squared plus b squared equals c squared. So 5 squared plus 4 squared equals c squared. Could I put 4 squared plus 5 squared?
Yeah.
That doesn't matter, right?
You put 4 plus 5 squared.
No. Will that work?
4 plus 5 equals 2 squared.
Is that the same?
Yeah.
It should be, right? Well, here, I get 41. If I do 5 plus 4 squared, well, that's 9 squared, which is 81. You see what I mean? Order of operations is still important, okay? Okay, and now, so C would be 6.4, okay? Because it was to the nearest 10. Okay? Do one more? Sure. Okay, so let's connect. Now, does it matter that I'm in the negatives over here on the x? No, because we're measuring distance, and distance is always what? Positive. So this has a distance of 2. We don't care that we're in the negatives. Don't let that trip you up, okay? Exactly. The numbers do not matter. The only time it would matter, let me address that in a second. Y'all get 7.3? Can you think of a time when it would matter? When I said the numbers on the coordinate grid do not matter. Anything?
If you're graphing it out yourself.
No. Anybody else?
If you mix up the C and
No.
the C value, or not.
No, that doesn't matter. What I'm saying is that whenever I draw a shape right here, I'm gonna go 1, 2, 3, 1, 2, 3, and I'm counting by ones. So when would it matter? And I need to pay attention. If for some reason my coordinate grid is not counting by ones, if it's like a graph and they're counting by tens or hundreds, you know what I'm saying? Then you would need to pay attention that it would be by one. But I don't think I'm seeing it correct. All right, guys, you try number 3 on your own, okay? And we'll check. Okay, you should have gotten 11.3. Anybody have a question on that? Are we good? Okay, so now on the next page, I'd like for you to work this with your table group. Okay, if you look at 4 through 6, notice that they're asking you to find the distance between the points. So what do you have to do first? You have to plot the points. So -6, 1. Let's just do that together. That means I'm going to go what? To the left 6. And then what? Up 1. And then -4. Is that 5 or 6? 1, 2, 3, 4. Okay, so there's your first set of points. All right. If you graph them incorrectly, are you going to get the correct distance? No. So you need to be very careful. Okay. So go ahead and finish the page with your table group. I'm going to give you guys about 12 minutes or so. Okay, sounds good, and then we'll check. Okay, check the answers. Do I need to go over anything else, you guys? No. So same thing here, right? I'm assuming. So that means, okay, from here to here, you should have got 9. And from here to here, we should have got 9. Then you needed to use Pythagorean theorem. And if you made one, this was 4, this piece was 3, then that's a 3, 4, 5. You didn't even hopefully you didn't even have like that. And then 5. So that means for perimeter, I'm adding all my edges 5, 9, 5, and 9 to get 28. Okay. Anything? How about the last one? Did y'all make 2 different right triangles? It could have gotten a little bit confusing because some people Mike have just connected those three like that. What's the problem with that? That's not a right triangle. You can't do that. Okay? All right. Anybody else? Anything else? All right. So the back page, that is your homework. Guys, as a reminder, tomorrow we have our half minor only on Pythagorean theorem. Is there a back page? The front and back, but it's the working. All right. And then a reminder, y'all, about math and math. Math and math. Those are due 2 weeks from now. 2 weeks from today, actually. 5 lessons worth 3 points each, 15 extra bonus points, okay? Okay?